Hello Gators, this is 4-3, proving and applying the SAS and SSS congruence criteria, day 1. I can use SAS and SSS congruence criteria to prove triangles are congruent. We looked at this video before. It's understanding the congruence criterion for congruent triangles. And it says if all the angles of one triangle and all the angles of another, all the sides of one triangle and all the sides of the other, if that is true, if all 6 pairs are congruent, then rigid motion will take place. And when rigid motion takes place, we have congruent triangles. Is there another way we can get triangles congruent with a lot less information? And the answer is yes. We can use what we call the SAS congruence criterion. It's where you use 2 sides and an included angle of one triangle and show that it is congruent to 2 sides and an included angle of another. Then the triangles are guaranteed to have rigid motion, and when they have rigid motion, they will be congruent to each other. Let's go ahead and look at a movie right now. And I want you to notice that we have a translation, we have a rotation, and then we have a reflection. So this is all the triangles are going to match onto each other. This means that rigid motion takes place, and therefore the triangles are congruent. All right, so let's take a look at this situation. We have 2 sides and an included angle, 2 sides and an included angle. Can we have rigid motion to map this onto the other? And let's take a look. Let's try to first take W, and we want W to match on to Z. So we want to imagine a translation going over here. Now, as soon as a translation, remember there's 1 tick mark here and 1 tick mark here. Once these match, you're going to want to rotate it so that this 1 tick mark goes on to the other. So this is going to be a translation followed by a rotation, and then the triangles will match. And this happens every time you have a side angle side situation. Let's take a look at practicing what included means. We have JK, that's this, and KM, that's this. So the included angle will be angle JKM. You have to use 3 letters because there's more than one angle K. Let me use green. KL, which is this, and JL, which is this, and the included angle, the angle between the 2 sides, is angle L. Now I can get away with angle L because there's only 1 angle L. Let me use a different color, blue. LK, we're still using this guy right here, LK, and KM, this right here. So the included angle is right here. I've got to use three letters, which is LKM. And this is how we find the included angle. It's between the sides. Let's decide whether there's enough information to show that the triangles are congruent. Remember that we only have one method, shortcutted method anyway, side angle side. The other alternative is to prove all 6 are congruent to all 6, which is not what we have here. So looking over here, remember side angle side stands for 2 sides and the included angle. So we have 2 sides, notice that 2 sides, and we have the included angle, and then we have another 2 sides right here and the included angle. So can we prove these triangles congruent? Yes, and we'll be using our only shortcut method, which is side angle side. Okay, over here we have 2 pairs of sides, and so we have the pair of sides, and we have another pair of sides here. And unfortunately, we do not have enough information. The answer is no. Because we're missing an angle. We don't know that this angle here and this angle here are congruent. There's no tick mark there to indicate that it's happening. What additional information is needed to show that these triangles are congruent by SAS? So far I see a pair of sides right here. So I do have a pair of sides, and I see a pair of angles. So I see a pair of angles. So the initial information needed is this pair of sides, this side and this side. And that's needed because the angle has to be included. So we need to show that AC is congruent to FD. That's what we need to show to be able to use side angle side. All right, let's go through a proof where we try to prove triangles are congruent by this shortcut method called SAS. All right, we are given CB congruent to CE. That is a side pair. I like to put little s here. We do have another, that's given, and we have another given, which is AC congruent to DC. I'm going to put a little s there, and that's given too. Now that's all the given, but we're being told that this angle right here is congruent to this angle right here. And we know that's true from other chapters we've had. Vertical angles are congruent, and that happens to be an included angle. That angle is between the two sides. So when this happens, the triangles are congruent by side angle side. Now let's take a look at this again. I'm showing it again. This is side angle side. And I want to point out something to you. I want to point out to you that we only use two sides and an angle. And that was the shortcut. We didn't have to prove all 6 of them. But now that the triangles are congruent, I do know some other information. I do know that AB is congruent to DE. The triangles are congruent, so the rest of the parts are congruent. And what else is congruent? Oh, angle B. Angle B gets to be congruent to angle E. Angle B is congruent to angle E. And 7, we have another pair of angles, angle A and angle D. So these are the pairs that we did not use, but now that the triangles are congruent, we definitely know that the rest of the parts are congruent. Now, why is this so? Well, it's our next theorem. It's called the corresponding parts of congruent triangles are congruent. The short version is CPCTC. And it says if two angles are congruent, once you've established the triangles are congruent, each pair of corresponding sides and each pair of corresponding angles are congruent. So when we used SAS, we only used 3 pairs to establish the congruency. Once it's established, the other 3 pairs that we didn't mention are also congruent. Let's go ahead and do a proof where I demonstrate this. So we're given parallel lines, and we're given AB congruent to CD. Now, remember that our only shortcut method right now is side angle side. So this is a pair of sides. Okay, remember side angle side means the pairs have to be congruent. Parallel is not congruent, so you can't use that as a side. All right, number 2, angle 1 is congruent to angle 2, and that's because if 2 lines are parallel, alternate interior angles are congruent. So the parallel lines were very helpful. They gave us a pair of angles. So I'm going to go ahead and mark this. This angle is congruent to this angle. And then we have AC congruent to AC. That's this side right here. This side is kind of a shared side, kind of like a next door neighbor sharing a common fence. And that's called the reflexive property of congruence, when something is congruent to itself. And that's going to be a side. Now when we label this side, we usually just put a little cross here, and that says that it's the side for one triangle and for the other at the same time. So this angle is included. This is side angle side. So we have established the triangles congruent. Now let's be careful with the letters. Let's make sure we can get the letters here. ACD, that's this triangle right here. I'm mentioning this triangle right here. Angle C on this triangle has to go with angle A on the top triangle. So I'm going to have to put an A in the middle. And remember that I want AC congruent to AC. So here's AC. So I'm going to have to write CA because AC has to be congruent to AC. And then the only other letter left is the letter B. So you got to be really careful how you put these letters together. So now we can say angle B is congruent to angle C because corresponding parts of congruent triangles are congruent. We've established the congruent triangles, so now we have these additional parts. And this is the end of the screencast.